Hello friends and my dear students. In the last session we have studied about standardization, interchangeability and limits. Today we are going to start our session from FITS, which is manufacturing consideration in design in your design of machine element 1 syllabus of 5th semester in B.Tech mechanical engineering course of Rajasthan Technical University. So let's get it started. As you can see, there are basically three types of fits, okay, which are called as clearance fit, interference fit and transition fit, as you can see in the picture as well. So in the clearance fit, in this type of fit, the size limit of mating parts are so selected that clearance between them also occur, means the mating parts are hole and shaft, means there should be some gap between the mating parts, which are called as clearance. Here, as you can see, this is the maximum clearance permissible till the tolerance limit. This is the red color, you can see this is the tolerance zone of both the mating parts. This is the tolerance zone of hole. This is red part, hatched red part is tolerance zone of shaft. So the difference between these lower limit of hole and upper limit of shaft, that is called as minimum tolerance. The lower limit of hole and or you can say the upper limit of hole and this lower limit of shaft, that this different distance will be called as maximum clearance in clearance fit. Now moving towards the next, which is called as interference fit, means the size limit of mating parts are so selected that interference between them is always occur, means there will be some interference between these two. Okay, as you can see in the picture, the lower limit of hole is going to lower limit of hole and upper limit of this, or upper limit of this hole, okay, upper limit of hole and lower limit of shaft, this will give you the minimum interference. Similarly, the lower limit of hole and upper limit of your shaft, that will give you the maximum interference, or from the picture you can directly depict that what is the minimum interference and maximum interference between the two mating part, that you can evaluate, and this kind of combination will be called as interference fits. Let's go to the transition fit. In the transition fit, size limit of mating parts are so selected that either a clearance or interference may occur depending upon the actual size of mating part. As you can see, there is some transition between these two, so this is called as your transition fit. Now as you can came to what is the meaning of tolerance here. It is a difference between the upper limit and lower limit of any of a dimension, which is called as our basic size. Okay, in other words, it is a maximum permissible variation in the dimension, means what is the variation allowed whenever a person or a worker manufacturing a shaft of diameter 20. Okay, so this much of permissible diameter is there, means he or she can produce plus minus 0.000 or 0.004, means either he or she can produce 20 or 20 minus 0.004. This much is permissible limit. And if, as you can see, one side upper side limit is 000, so this is, and other side there is some limit, okay, in the tolerance, so that is called as unilateral tolerance. If both side limits are there, means plus 0.002 minus 0.002, that is called as bilateral tolerances. So this is the method of assigning tolerance. Now let's discuss what is tolerance zone. As you can see, there is a zone between maximum and minimum limit of tolerance, that is called as tolerance zone. The hatched part of this hole and hatched part of this shaft is called as tolerance zone. We have already discussed that this is the maximum size till the tolerance and this is the minimum size, which is also called as basic size. Now what is the lower deviation and upper deviation? First we have clarify our tolerances, then we have fixed one basic size. As you can see, there is a zero line. From zero line to maximum part, that is called as upper deviation. From zero line to the minimum size, that is called as lower deviation here. Similarly, in the shaft you can enumerate that what is the lower deviation and upper deviation in the mating parts. Okay, so and this hatch part is also called as tolerance zone. Now, this is your broader picture of tolerance zone. As you can see in the picture, this is tolerance zone, this is zero line, and this is called as fundamental deviation or lower deviation. And this is your tolerance, this has dimension, and from zero line to the upper limit of tolerance, that is your upper deviation, and from zero line to the lower limit of tolerance, that is called as minimum size, or you can say your lower deviation. And this is your basic size. Zero line is nothing but your basic size. So all the deviations are there on the basic size, and from basic size you can also depict the minimum size and maximum size. As you can also whenever it is asked in university exam that how you can define lower deviation, actual deviation, then you can go with the theoretical version of this. Okay, now next is our surface roughness. Basically surface roughness, you know that there are some parameter, with the help of that you can calculate the surface roughness. So here we are having two methods, which is called as center line average method, CLA method, or root mean square method. So basically CLA method is defined as average value of ordinate or whatever value are there in which you are measuring the surface roughness between the surface and mean line measured on both sides of it. According to the Indian standard, the surface finish is measured in terms of CLA and it is denoted by RA. So CLA value or RA in microns will be depicted as y1, which is a ordinate or value y1 to yn divided by n. Similarly, if you want to calculate the root mean square, then definitely you have to take the arithmetic mean of squares. Okay, you have to take the arithmetic mean of squares of ordinates. So RMS value can be calculated with the help of this formula. Now, in Indian standard, following symbols are denote the various degree of surface roughness. This is inverted triangle. Surface roughness RA micron 8 to 25, then single triangle, single inverted triangle. For double 1.6 to 8, 0.025 to 1.6 in the microns we are talking about. Then 3 inverted triangle, 4 inverted triangle for less than 0.025 microns. Okay, now let's see what is the range of surface roughness. For different manufacturing processes, surface roughness is different. As you can see in the picture, lapping is having highest or very small surface roughness, as you can see in the picture, 0.012 to 0.016. Honing is having 0.025 to 0.4. Similarly, hot rolling having 2.5 to 50. Forging is having 1.6 to 2.5. Milling is having 0.32 to 2.25. Do not read to mug up all these things. Just recall that this is the sequence of for the range of surface finish, surface roughness or surface finish, you can say. Okay, so in this way you can figure out your which is better manufacturing process in consideration of surface roughness or surface finish. Okay, so I'm stopping here. I will come with the next session of design for casting, forging and machining parts, as well as design of assembly in the next session, which will complete your unit number 1. Thank you so much for your patience hearing, and stay tuned with our Engineering College Banswara YouTube channel for more such content of different branches of engineering like mechanical engineering, civil, electrical and computer science engineering. Thank you so much.